Hi there, welcome to Wagner Academy. This is Geometry, Lesson 4.2. We're going to talk about angles of triangles. Here's some of the new terminology for this lesson. We're going to be learning some new theorems and a couple of things called corollaries in this lesson. And make sure you use those extra examples in your books. Let's get started by filling in this table right here. These are the three biggies, the three big theorems in this lesson. First of all, we have in this one, this is going to be the angle sum theorem. Sum, S-U-M. So adding things together, the angle sum theorem, I'll abbreviate theorem THM. And this is theorem 3.1, so I'm just going to, or 4.1 I mean, I'm just going to put 4.1 in parentheses next to that. So you could refer to it, if you really wanted to, as theorem 4.1, but better referred to as the angle sum theorem. And so that theorem states that the angles, if you take any three angles, any triangle, you take the three angles in that triangle, they're going to add to 180. Their measures will add to 180. So let's write that down. The angles add to, you can write a little bigger than that. There we go. Add to 180 degrees in any triangle. So technically I would want to say the measures of the angles add to 180 degrees in any triangle, but I'm trying to give you a short and sweet and concise way to think about it in there. If you want to see the more formal way to state that theorem, please check out your book if you'd like to do that. But in this example here, I would say the measure of angle W plus the measure of angle X plus the measure of angle Y would have to equal, if I add those, that's the sum of those three angles, would have to be 180 degrees. Now over here in the margin, you can think of this, I'm not going to do a formal proof, but I'm going to do a description of why this works very briefly here so that you can understand why this theorem is what it is. So we haven't done a ton of proving different theorems that come out of the book, but this one, this is a description of why this works. So let's call this angle 1, 2, and 3. I drew an auxiliary line right there that's parallel to this side, and then by alternate interior angles I know that this one would be the same as this one, 2 and 2 would be the same, and 3 and 3 here and here would be the same. These three have to add up to 180. That means the three angles in the triangle would also have to add up to 180. So that's the basic idea. That's where this comes from. That's how we know any triangle that that's going to work out. The third angle theorem, some books might call this a third angles theorem. Our book says third angle theorem, singular. So the third angle theorem, this is 4.2. So it's the second theorem in chapter 4. It says that if you have two angles, I'm going to use some abbreviations here, two angles in one triangle that are congruent to two angles in another. So if that's true, that implies that the third angles are congruent. So let's look at the picture to make sense of that. What do I mean by that? So we'll start off with, let's put one arc mark here and one arc mark here, and two here, and two here. So if you have two angles in one triangle that are congruent to two angles in another triangle, like we have here, that means we can say, or this would imply, so this circle matches up with these triangles, and then this implies that the third angles are also congruent. So let's draw in the two arc marks again, here and here, one here and here, and in a different color. I would highly suggest that you put this in a third, for the third angle in a different color. We could prove, or we could say based on this theorem, that this angle, angle C, would be congruent to angle F in this particular case. So if we write that out, we would have, with this particular example, angle A is congruent to angle D, and we can also see that angle B is congruent to angle E. Those two pairs of angles being congruent implies that the third angles are also congruent. That angle C is also going to be congruent to angle F. So that basically is spilling over from this theorem. We've got two angles here and here, two angles here and here. They're supposed to add to 180. So this missing one, we know that these two, 180 minus these two would be this one. In the same way, that 180 minus these two, which equal the same thing as these two, would have to be this one. That means there's no way around it, excuse me. These two red angles, C and F, would have to be congruent. And then finally, the third biggie, the third big theorem for this lesson, the exterior angle, some books will say exterior angles theorem. So exterior angle theorem 4.3 is this one. This one says that if you have an exterior angle, so on this one I'm just going to show you some things here in the picture. This is an exterior angle. What makes it exterior? Well, it's not an angle inside the triangle, and if you continue one of the segments straight out, the angle that forms on the outside of the triangle is called an exterior angle. So this exterior angle equals, it's the sum of these two. We take this one and we add them together, we get the same value as this. Get the same value as what you have for the measure of angle 1. So it's the sum of, and we call these the remote interior angles. That's a fancy way to say it's the angles that are across from, not directly adjacent to, the exterior angle in question. So these are the exterior angle, the sum equals the sum of the remote interior angles. These are the remote interior angles with respect to this angle. So in an equation, we would have the measure of angle 1 equals the measure of angle 2 plus the sum plus the measure of angle 3. And then here being a picture again, why this works, I'll just quickly explain on this one why this works. If this is 1, 2, and 3, we know that this one would have to be 180 minus the measure of angle 1. And we know that these two together would have to be 180 minus the measure of this angle. Let's call this angle 4. So angle 4, the measure of angle 4 would equal 180 minus the measure of angle 1. You have a linear pair there. And then these two angles, the measure of angle 4 would also equal 180 minus those two added together. So measure of angle 2 plus measure of angle 3. So that means you have measure of angle 4 here and here. You've got 180 minus the measure of angle 1 then would have to equal, based on the transitive property, this equals this, and that same thing equals this other thing. You have 180 minus those two added together. And if you have 180 on both sides, we could subtract that from both sides. It would cancel out. You'd have negative measure of angle 1 equals negative of measure angle 2 plus 3. You could divide both sides by negative 1, and you'd have the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So based on linear pairs and the angle sum theorem, you can derive this theorem as well. I'm not going to expect you to know how to do that, but that's how it works out. That's why it works out. So I just wanted to show you in this lesson why those things work out. Now, find the missing angle measures. We're going to do that, practice that using the theorems we have here. I did this because I feel like if you can understand where things come from in geometry, mathematics in general, then it's just so much easier to use those theorems. You don't have to memorize things because you have this idea or understanding of where they come from in the first place. But finding the measures in this picture that are missing. So this one's missing 1, 2, and 3. I know based on the triangle sum theorem, if I add these three together, or the angle sum theorem for triangles, if I add these three together, I should get 180. That means measure of angle 1 would have to equal 180 minus these two. So I could take those two and add them together first and then subtract that from 180, or I could do 180 minus 85 minus 32. Both those things would do the same thing for me in my different color, I'm going to write my justification for at least the first step for each one of these things. So this is based on the angle sum theorem, and I'll use my abbreviations for things here. So this is based on the angle sum theorem. That's where this equation is coming from. So we've got 180 minus these two added together is 117, and that then equals 63 degrees. So as I start to figure things out, I'm going to fill them in, or I'm going to label them in the picture. So that's 63 degrees. What's that mean the measure of angle 2 has to be? Well, these are vertical angles, making these two perfectly straight lines together. So that means the measure of angle 2 is very easy to calculate. I don't really have to calculate anything. I just know it's the same thing. Vertical angles are congruent. So that one would also be 63 degrees. So this is vertical angles. That would be my justification for that one. And then let's label that. This is 63 degrees. If I know this one's 63 and this one's 41, I can use the triangle sum theorem one more time to say that the measure of angle 3 would equal 180 minus these two added together. So minus 63 plus 41. That would give me 180 minus, this would be 104. And that would give me a final answer of 76 degrees for the measure of angle 3. So I'll fill that in. You can verify your answers by adding the three angles here, seeing that they add to 180. Do the same thing with the angles, three angles here, and see that they add to 180, and they in fact do. Example 2. It says find the measure of each numbered angle in the figure. So we've got 1, 2, 3, 4, and 5 different angles to figure out on this one. I thought this kind of looked like mountains and reflections, and it just reminded me of that. So I love mountain scenes like that. It's so beautiful, so beautiful. And being there, in person is 100 times better. If you ever get a chance to go backpacking way up in the mountains somewhere, do it. Take the opportunity to do that. First of all, this angle right here, angle 1, how can I figure this one out? I have them numbered in a way that we're going to just do them in order. It might not be quite that easy where you can just do them in order in the future, but this one it's going to work out that way. I know based on the exterior angle theorem that this one has to equal, the exterior angle here has to equal the sum of the two remote interior angles, so the two that are across from it. So I know that I could say the measure of angle 1 would equal 37 plus 63. And again, that was based on the exterior angle theorem. So that's this one right here. We're using this theorem right here. So I have this measure of angle 1 is going to equal 100 degrees. Same thing as before, I'll fill in the numbers as I calculate them. I think that's a very good idea. It's going to help us to see much more easily, much more clearly what the next ones are going to be. So angle 2 and 1 together, I hope that's pretty clear. That's a linear pair. And so those are supposed to add to 180. That means I could do 180 minus 100 to get the measure of angle 2. That would have to be 80 degrees. So what was the reason for this working? That was a linear pair right there. Now I know this is 80, and I don't know 3, but I do know this one. So I have another exterior angle here with respect to this triangle. So this exterior angle has to equal these two added together, these two remote interior angles added together. So I could say, I could set up an equation like this. At 125 degrees, the exterior angle equals the measure of angle 3, the one I'm looking for, plus the one I just figured out, 2, was 80. And then I can do basic algebra, solve for measure of angle 3. Get that by itself. You can subtract 80 from both sides. This is going to end up being 45 degrees for the measure of angle 3. So this one was the measure of angle 2. This one was the measure of angle 1. Now the measure of angle 4 Now that I know what 3 is, let's see if that helps me figure out 4. It looks like I didn't really need to know 3 to find 4. So this is 45 degrees, but I did need to know that this is 125 degrees. So another linear pair, that means I can do 180 minus this angle to get this angle. 180 minus 125, that gives me 55. So the measure of angle 4, 55 degrees. We're almost there. We almost got all 5 of them. So this is 55, and I need to know that one to figure out 5, because this one and this one together, added together, that's the exterior angle theorem. One more time, we have those two together, it has to equal this one. So let's write our justifications here. Next to these, this was the exterior angle theorem for angle 3. Angle 4, this one was another linear pair. And now angle 5 down here, this is going to be the exterior angle theorem one final time. And that equation set up correctly would look something like this. You've got the measure of angle 5 equals, you could say 55 for first or 38 first, it wouldn't make a difference, but equals those two added together. So 5 is going to equal 93 degrees. And our final slide for this lesson, this idea of flow proof, that's what goes in these two blanks, it shows up in this lesson. So I just wanted to introduce that. We're not actually going to do a flow proof together, but a flow proof organizes a series of statements into a logical order. Proofs are all about logic, so using the things you know to prove some new things and having to go in a logical step-by-step manner to figure those things out. So a flow proof, logical order, starting with the given statements. Statements are written in boxes. This is a miniature example of a flow proof. So boxes here, the gray, and then you write the verifications underneath those boxes. So reasons verifying them below each box, and arrows are used to indicate how the statements relate to each other. So they have things flowing together, kind of like a river, a stream, and then this idea flows together to this idea and to this idea. These ideas flow together, and then they all flow together in the end to give you what you're trying to prove. This is the final thing that you're trying to prove right here. And you can check out page 187 if you'd like to see an example of a flow proof. But a statement that can be easily proved using a theorem is often called a last new vocab term for this lesson, corollary. Corollary, 1R, 2 L's. So a corollary of that theorem. So we have two corollaries that are introduced in this lesson. This is corollary 4.1. It's the first corollary in chapter 4. This one's going to be corollary 4.2. It's the second corollary in chapter 4. Both of these things flow from or come out of theorem 4.1, the angle sum theorem. So both of these things are corollaries to theorem 4.1. So this one says that if you have a right triangle, which is clear, I have a right triangle right here, that the acute angles, these two, this one and this one, the acute angles in a right triangle add to, can you take a guess? If this one's 90 and they're all supposed to add to 180, these two have to be 90 together. So they have to add to 90 degrees. So that comes out of the idea that all three triangles in, or all three angles in any triangle add to 180. If one of them's 90, if one of them's right, the other two have to be 90 degrees complementary, in other words, to each other. So in this example, we have the measure of angle G plus the measure of angle J would equal 90 degrees in this particular triangle. So that's one corollary. And then the other one says that, and we've talked about this already actually, but right, somewhat small on this one, no more than, this is the idea, this isn't a formally stated way to say this, but there's no more than one right or obtuse angle in any triangle. So that's the big idea here. So these two, you have a right triangle. These have to be acute angles. Why do they have to be acute angles? We talked about that a little bit already. But remember, they add to 180. This one's 90. These two have to have some sort of measure, even if it's really, really small. So these two would both have to be acute, because these two have to add to 90. And then if you have something that's bigger than 90 here, these two, same thing, the triangle, the angles have to add to 180, so these two must be acute as well. It's the only way to have a triangle that's obtuse is the other two are acute. So, example 3. Let's use this idea, one of these two ideas here, to figure out, to find what we have here. So the measure of angle 1, if the measure of angle 2 is 36 degrees. So let's label that on our picture. We're saying this one is 36 degrees. And I could say 180 would equal 90 plus 36 plus the measure of angle 1. Is that going to work still? Yes. But we might as well use this shortcut, this corollary, to find it quicker. So I can say, since this one's a right triangle, you have 90 right here, these two automatically must add to 90 right there. So I could say, more simply, the measure of angle 1 plus 36 would have to add to 90. From there, I could subtract 36 from both sides, leaving me with what I want to figure out, the measure of angle 1 by itself. So here the measure of angle 1 equals 54 degrees. And you could plug that back in or think about it in the context of the picture. 54 plus 36 plus 90, add those three together, you get 180 like you should. So that does it for this lesson. I hope you have a great day. As always, make sure you use extra examples in your book. Make sure you know these terms and these theorems, how they work. Make sure you understand how to use them in the context of problems like we did. And again, have a great day. I'll see you for our next lesson, 4.3.